Hi Meredith. Thank you for your question. That's perfect if you send me a picture like that. I've actually seen this question once or twice last week from some of your classmates who came in as well. Unfortunately, I can't turn it around on this program, so I know it's sideways, but I'll write the proper way up as we're talking so that you'll understand what I'm doing here. So this one is all about patterns, and if you follow the pattern that you see here, when you start with the squared relationship, squaring the binomial, you end up with one of the a squared, one of the b squared, and then you end up with two of the combined terms, like the product of the two bases, a and b, or the two variables. So if you move on and you square a trinomial bracket, then each of the terms in the trinomial bracket gets squared individually, and then you also end up with one case where each of them is combined, so you get A combined with B, A combined with C, and B combined with C, and that's the only way that you can combine those terms in pairs. There's three different ways that you can make pairs out of them, and it turns out that we end up with two each of those. And so it's following a bit of a pattern already based on what we saw in the first question. And in the second question, now we've got three of the combinations. Here we only had one of the combinations, and we've got one each of the terms squared. So what they want you to do, and I'll start writing the right way up now, for part A, what they're asking you to do really is to use the pattern from the previous two examples to predict what that one is going to look like. So the first part is easy. You're going to have your a squared plus b squared plus c squared plus d squared. And then what you need to do is figure out how many combinations you're going to have for the pairs. So we can have A with B, A with C, A with D, B with C, B with D, and C with D. And so I think there are 6 combinations that I said there. And then we need to figure out how many of those we're going to end up with when we're expanding that pattern. One way to think about that is that you are squaring this polynomial term. In other words, we're multiplying two of the identical brackets times each other. And so we're going to have two occasions where you're multiplying the same two variables together. So in the first case, let me write over here and show you what I mean. We would have like A plus B plus C plus D times A plus B plus C plus D. So you're going to have A times A is A squared, A times B is AB, and then later on we're going to start with B and multiply into that next bracket, and so we'll end up with BA, which is the same as AB. And so you're going to have two cases where you're going to end up with a product of AB, so there will be two of those. And so what we really need to do back over here is keep that same pattern and write out 2AB plus 2AC plus 2AD plus 2BC plus 2BD, and I'm going to run out of space here, plus 2CD. And I think that takes care of it. And I think that's 1, 2, 3, 4, 5, 6 combinations, okay? And so what's happening here, if we stop and take stock of our pattern, is that each of the individual terms in the bracket get squared. So depending on how many of those are in the bracket, we'll have that many terms squared. And we seem to be going up. In the first case, when we had a squared bracket, we ended up with one of the combined terms, the 2AB. When we had two terms in our bracket. When we put three terms in our bracket, we ended up with three of the two, AB, 2AC terms. If we have four terms in our bracket, we end up with 6. and so on. And so if you're predicting that pattern and following that pattern, if we put 5 terms in the bracket, it looks like we should have 10. 6 terms would give us 15. We're just adding one more on each time. So this pattern that we have shown here is actually sort of a common pattern. It looks like it's triangular numbers. It's going up by one more each time. What's a little bit different about it is that it should start at 1 and 1, not 2 and 1. So it doesn't follow the basic formula for the triangular numbers. But we can see that it's going up by 1 each time, and if we can find some kind of a pattern related to n, which is the number of terms in your bracket, and the result, which is the number of combinations of those A, B, and B, C, and C, Ds, then we could probably write some kind of general term for that. So for part B, that's what we're looking at now, is to figure out if we can do some kind of generalization. So extend the pattern when you're squaring any number of terms in a bracket. And so we would end up with, a to the 1, a squared, a to the 1 squared, plus a to the 2 squared, plus a to the 3 squared, plus dot, 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 all the way to a to the n squared. And that would take care of squaring all of the individual terms in your bracket. The other part is going to be a little bit more difficult. We've got to figure out how many of the 2 ABs and so on. I think you would be okay for this assignment for you to write 2 A1, A2 plus 2 A1, A3 plus, and then just go dot, 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 and the very last ones would be 2 an minus 1 an, because that's the an would be the very last term, and the n minus 1 would be the one before that. And I think if you show it like that, and maybe with a little bit of explanation, it never hurts with math for you to write a little sentence explaining what you're doing. It makes it much clearer to the person who's marking it that you understand what you're talking about. That I think that would be an acceptable response for this question. So if you have any other questions, feel free to email them over, and I think this is due this week sometime, isn't it? Can't remember what they told me, but maybe Thursday or something like that. So let me know, get in touch if you need help with anything else on that assignment, okay?